Well, I have been away for a weekend break, but I'm back now, as you can probably tell. Before I went away, I wasn't exactly lazing around. I did spend an hour or two each day out in the workshop, and this is the result of my labours. I've attached the ram slide adjustment brackets to the bull wheel. I've made the link which slides in there. It is, hopefully. Let's get it in the right way around. I'll tell you what, I put it in the other end. It went in there before. Now, here we go. Obviously, of course, it makes no sense to have it full width, I realise now, because you can only go from the centre to the outside, which is the same on t'other, but there we go, it's done now. And that connects the to the no, not there. That sliding block goes onto this well, bolt, I suppose you'd call it, threaded portion. That in turn goes inside here. Obviously it entails taking it apart, but that will slide up and down on here as the thing goes around. Oh yes, and I have been round taking all the sharp edges off, and I've put the bushes in the end, reamed them and smoothed them off flush with the face. One end of this goes to the rocking arm. I've got a temporary pivot on here. That won't go in that way either, so not my day, is it? There we go. Got it the wrong way round. Oh, that's won't go in because there's a grub screw which locates on what will be a flat milled on the pivot, and I've screwed it in a bit too far, as you can possibly see, and of course it won't go through. But there we are, you get the idea. This mounts on the base plate, and there's another pivot that goes through there, and this allows the arm to articulate. What else have I done? Oh yes, when I came to mount it all together as a trial fitting, I realised of course that I hadn't drilled the holes for the that's the drawing. I hadn't drilled the holes for the mounting of the vertical slide. So I've got a set up in the mill. You can possibly hear the mill VFD going in the background, and I'll take you over there now and show you how I'm going to get around that little problem. Here we are then over at the mill, as you can see. I've got the two plates, the base plate and the top plate, bolted together using the column fixing holes and tapped holes in the top plate. They're bolted together just to give them some alignment. The edges of the two plates are not exactly smooth, so I can't use those as a reference. What I've done is lined up on this hole here, which is the mountings for the spindle support, and using the coaxial centering device, I got it lined up as best I could. Let me just zero that, switch it on, hope that it hasn't moved. It twitches a little. Better when I align it up, but that's, you know, as near as a gnat's knickerleg as I can get it. The hole itself is a bit rusty. What I'm going to have to do is use that as the origin, and the holes I need to draw are these two here. Obviously they align excuse me, top and bottom with the plates, which is obviously why I've got them screwed together. So what I'll do, I'll drill through the bottom plate in these two places and into the top plate by about 7mm, because the top plate is going to be as best I can not have any through holes in apart from where the files will poke through, and they will be aligned by dowels. This end will be screwed in the same way as the bolts for the column, etc. are recessed in here. So got to move it over to the new positions, which I've taken from the CAD drawing. So not very focused, is it? But there we are, I can read it off the drawing. So move it over, spot drill, and then start off, and I'll probably go in with a 5mm end mill just to make sure that I'll get a flat bottom and they'll get the distance correct. So there we go, that's the plan. I'll now change out the centering device for a 5mm carbide mill, and well, that's confusing, isn't it? 5mm carbide mill, and get on with the gouging. Okay, so I've swapped out the centering device for the ER25 collet chuck. I've put in a 2 flute carbide end mill. Sorry about the kids playing in the lane next door. And now I'm about to start the mill up, the spindle, and bring the knee up so that the cutter just contacts the top surface of the bottom plate. Which is there. I will actually stop the spindle. I've got to reach around the camera and zero the Z-axis. Now each of these plates is 10mm thick, so obviously I need to go down 10, and then I think I'll go down 7mm into the top plate, giving me 3mm to play with for the dowel to sit in, which would be ample. Not sure how this is going to go. I think I might just peck it a bit to start with and see how we get on. So off we go. Right, that's that done. I think I'll use another end mill just to cut a counter bore in there, so I'll quick measure up and I'll find another cutter to do that. Okay, change done. I'm going to use a 10mm 2-flute end mill cutter, simply because it's the sharpest one in the box, really. I've already zeroed it, as you may be able to see in the Z-axis. I'm intending to use 5mm button head screws for securing it, and to get them just under the surface of the bottom plate I only need to go down 3.5mm, and that should give me sufficient clearance. So here we go. There you go, 0, yep. Here we go. 1.5, 2.5, 3.5. Simple as that. Now we all breathe a sigh of relief and hope that works. Having finished the holes for the mounting of the ram slide in the bottom and the top plates, I thought I'd have a bit of a sanity check and do a trial assembly of the motion to see whether the well, basically whether I've put the holes in the right place. So what I did was I've mounted the spindle, as you can see, and the pulley wheel, the bull wheel, the ram pivot mounting, and the motor mount. I found that the motor mount didn't line up, the holes didn't line up to give a suitable tension on the belt. So what I did is put a couple of temporary screws in, and found that by leaving a space of 5mm underneath, you can see that very well. Try and get a bit closer. That gave me a sensible tension on the belt, and also allows the motor mount to sit on the base plate. Okay. Before I machine out a new mount, I'm going to make a small spacer to go under there just to check everything is hunky-dory. I've sketched it out in CAD, on a step file, and in Fusion 360 I've produced the G-code for that. The computer is just warming up, and I've got a bit of leftover 10mm perspex from cutting out the quill lamp, and I'm going to use that to make a spacer just to try out my theory before I actually go and cut some more scrap up to make a new motor mount. So let's go over to the router and see what's happening. After a little bit of jiggery pokery and rotating the piece of scrap here through 90 degrees because of the orientation of the file, I'm about ready to cut out the temporary bodge fix. First off, I will run a program which will face the thickness down by 5mm in the middle of the cutout. Then I'll bore out the two mounting holes, and then finally another run to cut out the outline, leaving it with tabs on the bottom which I'll need to break out and break off. So here we go with the first one. This is to face it to 5mm. Well, hopefully I would have either speeded it up or cut out a big chunk of that in the middle, probably both. So I'll change the program and we'll come back and do the next one, which will be to bore the two mounting holes in the section there. About to do the holes, so I'll bring you in a bit closer for that, and we get a, hopefully we can see what it's doing. Shouldn't take long. The holes are only 5mm diameter, and the I've got a 2 flute, or is it a single flute? Single flute, 4mm cutter in the up the spout of the router. So here we go. Start the job. Start. I need to change that. Here we go. As you can see, quite a lot of engineering goes into that, and it wobbles the old table around a bit, but never mind, it gets the job done. Right, load up a new file and we'll cut out the outline. Unfortunately, the video camera didn't pick up this contour cutting, so we'll move back and carry on with the setting up of the components. Back on the bench with a couple of overly long screws just holding that mounting in. I've put the riser plate on, and just to prove the process works, the tension on the belt is adequate. more than adequate, I would say. But there we go. It's done. It's proved its worth. So off camera, I will spend a half hour or so cutting out a new motor mount, which will be 5mm taller. May not be doing that straight away, because this is working okay once I've cut down those mounting screws, and until it's all finished, and then I'll probably redo the mounting. Off camera again, I'll cut up some new pivot pins made out of silver steel, mill a flat on the end so the grub screw can locate. That will then allow me to put the ram link on. Obviously that goes in there. The ram link goes, oops, daisy. The ram link will go in there. I'll put the bearing slide in. The bearing slide bolt. And then I'll offer up the raw material for the ram slide and see how that lines up. Fingers crossed it'll be okay. At the moment it's in the mill vise, just being squared up and milled to the correct length. Right, I think that'll probably do for this video. When we come back next time, I will have the mock-up complete. I'll take the ram slide metal out of the vise and offer it up, and we'll see how we get on there. So until next time, if you have been, thanks for watching, and I'll catch you next time. Bye.